Hello everyone, welcome to the page 2, chapter 8 study guide. So the first set of directions for the first 4 problems says to determine whether the figures can be proven similar. So I want you to think to what it means to prove that 2 figures are similar to each other. The corresponding angles between the shapes should be congruent. All corresponding angles should be congruent. And then all of the corresponding sides are not going to be congruent, but corresponding sides are going to be proportional, meaning that they all reduce to the same fraction. Okay, so the first thing we always do and did in class whenever we did this pocket sort thing that we did is we said, do the shape or the shapes the same? If that was true, we kept going and we said, okay, are all the angles the same? And then we looked at the side lengths and we checked all the fractions. So let's do that here. It says, if so, complete the similarity statement and write the scale factor if the left image is the original and the right image is the new. So let's write that out. That just means that this one's the new one, this one's the old one. So when we write a scale factor, we have to go new over old. Okay, so let's look at our corresponding pieces here. Of course, the 30 corresponds with the 36. The 15s correspond with the 19.4s, and the 20 corresponds to the 23. So the first thing I'm going to do is I'm going to check all of those fractions. So does 30 over 36 reduce to the same thing as the others? So when I reduce 30 over 36, I'm going to divide those both by 6, which is 5/6. That's fully reduced. Let's check that with the 20 over 23. 20 over 23 is actually already fully reduced. So immediately I can stop because those two are not the same, which means that there is no scale factor because these are not similar. These are not similar. You could check the 2 greens as well, the 15 over the 19.4. And you could do that as a decimal and see that that decimal is not the same as 5/6. Or you could turn that into the whole numbers, which is 75 over 97, I think. And that does not reduce, but that would not even give you the same fraction as 5/6 or as 20 over 23. So these are not similar for sure. Okay, number 23 is a little bit tricky because these appear to be rectangles, but we do not know that for sure. And why do I not know that for sure? Because I don't know these angles. I don't know any of these angles. And so it appears the shapes look about the same, but when we go to check the angles, I don't have any information on them, and these are not triangles, so I can't use any of my shortcuts. So immediately, I don't even have to check the 9 and the 6 and the 6 and the 4, even though those will reduce to the same thing. Because we do not know congruent angles, we're going to say, not necessarily that they're not similar, but just that we don't have enough information to say that they're similar. Okay, so at this time, we would need more information. So there's not enough information to say if they're similar or not. If I knew that those were rectangles, or if it told me that they were rectangles, then I could add the 90-degree angles. And then I could say, okay, well, 4 over 6 is 2/3, and 6 over 9 is 2/3. But I do not know that, so I'm going to get to stop at the angles. So we're going to say at this time, there's not enough information because we do not know that these are rectangles and we don't know the angles. So I have to say not enough information to say that they are similar at this time. Okay, now these are rectangles. Why do I know that? It's a 4-sided figure that has 4 right angles. And so all of the angles, all the corresponding angles are congruent. And now we can check the corresponding sides. So who does 25 correspond to? Those pieces that are 5. And then who does the 15 correspond to? Those pieces that are 3. Okay, now this is a little bit interesting because it says the image on the left is the original and the image on the right is the new. Well, obviously we don't have left and right here, so we're just going to check the pieces. We're going to assume that the middle one is new and then the outside one is old. So our scale factor should be, it's getting smaller, so it should be less than 1. So we're going to see, does 5 over 25, which is 1/5, does that reduce to the same thing as 3 over 15? 3 over 15 is in fact 1/5. So this does get smaller. Those are both the same, 1/5 and 1/5. And so the scale factor is 1/5 the amount. And HIJK, I'm going to name this other one in the same way. So H corresponds to QRST. So these were similar with a scale factor of 1/5. Okay. Do these shapes look the same as far as the same shape? Yes. So now I'm going to check the angles. Do I have the corresponding angles congruent? So 45 goes here. The 90, let's go different color. 90 goes here. the 140 is in the same spot, and there's a 95 piece. So this has been rotated some, but those are in corresponding positions, and those angles are congruent. So let's keep going. Now let's check, the last thing you have to check is all of the fractions. And so if I'm trying to see who goes with pink to blue, that 4 piece, that's going to go pink to blue, which is the 10 piece. So I'm going to compare the 10, let's do that in colors, 10 over 4. 10 over 4 reduces to 5 halves. So let's see if that happens with the others. Okay, let's look at the piece that is between the purple and the blue, which is the right angle. Purple and blue is 3. So I'm going to check 7.5. 7.5 over 3. That is going to be 2.5, which is 5 halves still. Okay, let's keep going. Let's do that again. Let's find another color to work with. So let's work with between yellow and green and purple. Green and purple would be 2.2, so 5.5 over 2.2. 5.5 over 2.2, which is going to be 5 halves. You can check that as a decimal if you needed to. That's going to be 2.5. And then last but not least, we have our remaining piece, which is going to be the 14 and the 5.6. 14 over 5.6. You could check the decimal again if you wanted to. It's 2.5, which is going to be 5 halves. Okay, so what is our scale factor? 5 halves. JMLK is going to be similar to J, so starting at J, which is the 140. So we want to start at the 140, which is R. So RTSU. So these are similar. This is going to be the new one. This is going to be the old one, so it does get larger. So 5 halves makes sense, or 2.5 as a decimal, but we want to write it as a ratio. So the scale factor is 5 to 2. So it does get larger. All right, so let's start with a set of directions because this is important. It says given the shapes are similar, so that's important. If the shapes are similar, we can use scale factors to find unknown ratios, so solve for the indicated value. So let's look in this picture at what's already in the same spot. AB is the first 2 letters. Who is that corresponding to? TS. So these are also the same. So we are given that they are similar, and we want to solve for the unknown value. So I'm able to set up a proportion because these are going to be, the blue pieces are going to be corresponding as well. And so when I set up this proportion, there's 25.5, there's 17. I'm going to do 25.5 over 17. That's how I chose to set it up. Would be equal to the one on the right, the bigger one, 3y plus 6, over the smaller one. So TU is going to go with AD, which is this piece right here, 3y minus 3.5. And so we're going to cross multiply here. And again, since I've already done this earlier in the video, if you need help with that, come to see me. But we're just cross multiplying here. So it's 25.5. You're going to use the distributive property. So 25.5 times 3y minus 3.5. And I'll set that equal to 17 times 3y plus 6. Again, just distribute. If you need help with that, come see me with the algebra. What you end up finding is that y is equal to 7.5. Y must be equal to 7.5 if these shapes are similar. All right, now number 27 does not have a similarity statement, so we're going to have to use our diagram. So the first thing I notice is that I know that I'm going to have vertical angles that are congruent. So those 2 angles are going to be congruent, and then these 2 angles are marked as congruent. And then finally, we've got the unmarked angles. And so when I'm looking at what pieces go together, I use the angles to help me determine. So like I know that the 9 is going to correspond to the 19.8 because those are both across from the purple angles, which are the vertical angles. The 5 is across from the blue angle. The 11 is across from the blue angle. So those are going to correspond. And then last but not least, the X is going to correspond to the 6. So as far as looking at pieces that are both known, 19.8 is going to correspond to the 9. So when I'm setting up a proportion to solve for unknown pieces, 19.8 over 9 is going to be equal to, 19.8 over 9 is going to be equal to X, because that's the one on the bottom, over 6. I could have also used the 11 and the 5 had I wanted to, either way. 11 over 5. And so when I do that, I end up getting 13.2. 13.2. You would get the same thing had you worked with 11/5 instead. So whenever you cross multiply, again, come see me if you need help with that, but that's 19.8 times 6 and then divided by 9, which is 13.2. I do want to show you that this works out the other way as well. Let's say you had worked with 11 over 5. 11 over 5 would still be equal to x over 6, and so that would be 11 times 6, which is 66, divided by 5, which is still 13.2. So both of these give you the same thing. Both of those give you 13.2 for x. Okay, we said whenever we see a problem like this, we're going to slow down because this tends to be where people make mistakes. So what I have is I have a small triangle over a bigger similar triangle. It does say that they're similar, so I've got my my pieces that correspond. This is where we slow down a little bit. This is the full top of the little triangle. This is the full top of the big triangle. This is the left-hand side of the little triangle. This whole thing is the left-hand side of the big triangle. And then here's my right-hand side of the little. Here's my right-hand side of the big. So if I wanted to say what is the right-hand side of the big triangle, I'd have to go 4 plus 2, which is 6. So as far as finding an unknown length, if I'm going to compare the x to the 12, I need to compare, for the yellow piece, I need to compare the 2 to the whole thing, which is 6. 2 over 6. X over 12 equals 2 over 6. I'm not going to work with the pink piece here, simply because I don't know what this whole thing is. I could find it if I wanted to, but they don't ask me for it, so I'm just going to stick to where I'm at. So again, we cross multiply, so 24 equals 6x, so x equals 4. X equals 4. Again, you can plug it in and check it. If you wrote a 4 here, 4/12 is 1/3, so is 2/6. So you know that you're doing that math correctly. All right, let's look at the directions for the last set on this page. Now, we're working with triangles here. That's important because we know that we have 3 shortcuts for proving triangles similar. We have side-side-side similarity, we have side-angle-side similarity, and I have angle-angle similarity. So even if I'm missing information, I'm able to use those shortcuts to say if 2 triangles are similar to each other or not. So like on number 29, even though I don't start with knowing the angles, and I don't start with knowing any sides, I do see that I've got these little parallel markings. If these lines are parallel, I get to add corresponding angles at W and E, as well as at V and at D. And then, of course, we know that they overlap at U right here. U is in both of those triangles. And so even though I don't know anything about the sides, I do get to say that these triangles are similar by angle-angle similarity. Says that W to U to V is going to be similar to E to U to D. So that was using one of my shortcuts. Number 30 appears to be side angle side. So what I'm going to do is I'm going to write SAS question mark. Well, I'll write SAS similarity question mark. That's what it appears to be, but we always need to trust but verify. So first let's see, are the angles in the middle congruent? And yes, that angle checks off. But now we need to check, does the ratio of 5 to 10 reduce to the same ratio as 14 to 28? Which of course y'all know that it does, but let's write that down just in case. 5 over 10 is 1/2. And then 14 over 28 is 1/2. Since those are both 1 to 2, it does not specify what the scale factor is or what the similarity ratio is. And so what I get to say is by SAS similarity, WUX, that's WUX, is going to be similar to UTV. If I ask you for the similarity ratio, you'd say 1/2. If I said, what is the scale factor, you'd have to know which one is new and which one is old. So new over old would be 1 to 2, or if I flip-flop that, it'd be 2 to 1. But they don't ask for any of that, so we get to stop at just saying that they're similar by side angle side similarity. All right, these shapes do appear to be similar, and I think that's what we're, list the reason. So they appear to be similar. They're not touching at vertical angles this time. It appears to be similar by side angle side similarity, but I need to check my 3 fractions. So here's the 15. That's going to correspond to the 30 because those are both the larger pieces between the 2. And this is an isosceles triangle because 2 legs are the same. So those two 26s are going to correspond to the 13. So let's say that I go left to right and I decide to do 26 over 13. Obviously, 26 over 13 is going to reduce to 2 over 1. I could check that again. There's really no need to rewrite it, but that other 26 over 13 is going to reduce to 2 over 1. And then let's check the green piece. I went left to right the first time, so I'm going to do that again. 30 over 15, I believe. 30 over 15 also reduces to 2 over 1. So all sides reduce to 2 over 1. And so they are similar by side-side-side similarity. NML is going to be similar to PQO. You could also do or triangle OPQ because those are isosceles. Those legs are congruent. All right, let's check number 32. Number 32 appears to be a side, 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 but I'm going to put a question mark there because we need to check the corresponding pieces. So 12 is the smallest piece, so it's going to correspond to the 8. Let's write that out real quick. 12 over 8 is going to reduce to 3 over 2. Okay? And then I'm going to check the next piece. Let's see. If I chose 30, that's the medium piece. So what's the medium piece over here? That's 20. So if I did 30, oh goodness, 30 over, go to color, 30 over 20 reduces to 3 over 2. So far, so good. We'd get to stop there if not. And then last but not least, the 36 corresponds to the 24 because those are the biggest pieces. So 36 over 24, both of those are divisible by 12, so that's also 3 to 2. So since all three of those are the same, then this is side, side, side similarity. And triangle ABC that went across green, across purple, and then across orange, across green, across purple, and across orange would be OPN. Triangle OPN is in fact similar to triangle ABC by side, side, side similarity. All right, number 33, we've got to be careful on these because number 33 appears, if I had to guess, what's marked to be angle-angle similarity. But what I noticed at the very beginning is that so far, let me highlight this, I only have one angle congruent to one angle. And then I have a 48, which is different than the 63. So what we have to do before we make this decision is find that third angle. So what is the third angle right here? Let me mark that a little bit darker. What is the third angle right here? The third angle right here is going to be 41 degrees when you find it. The third angle right here is going to be 56 degrees. So 56, 48, 41, 63, those are not the same. So this is not angle-angle similarity. These are in fact not similar. So you could write not similar, which means I am not going to have a scale factor. So you can either write not similar again, or you can just, what we've been doing is just crossing it out. The shortcut is not going to exist. We're not going to have a scale factor, and these are not going to be similar. We know for sure that they are not similar. All right, let's do this one last time. 2.1 is going to be the medium piece. So what's the medium piece over here? 3.5. Got to be careful there. That's medium. So what's the smallest piece is 1.8. So that goes with the 3. And then, of course, the 3.6 and the 6. A lot of these are decimals, a lot of these are decimals. So if you want to turn those into, to see what they are as a decimal, that's fine. So if I did 1.8 over 3, I could check what that is as a decimal. And it should be the same thing, but that would reduce to 3/5. If you can't get that to happen in your calculator, come show me, and I can help you out with that. Okay, so I went left to right here. So I'm going to go left to right again. 2.1 over 3.5 is also going to be 3/5. It's going to be as a decimal, that would be 0.6. Okay, so I'm going to write up here 0.6, which is 0.6. Okay, so last but not least, we've got our blue pieces. So 3.6 over 6, when you divide that out, that's going to give you 3/5, which is also 0.6. So all of those we know for sure are going to be in the same proportion. So side, similarity says that these are similar even though we don't know anything about their angles. And so PQR, pink, yellow, blue, would be UTS. So this was page 2, and I will be making a page 3 soon.